All right, welcome back. This is Lightning Review 3, where we're going to talk about regular expressions. This is a companion video for Lecture 2. And the relevant stuff in CIPSR is CIPSR pages 63 to 65. So, as a reminder, at a high level, regular expressions are a shorthand way to represent regular languages. So, they're a notation that tell us how to generate all the strings in the language. And they use regular operations like union and star and concatenation. And we define them inductively as follows. So the inductive definition, a regular expression is well, it's some symbol in our alphabet, which, to be clear, when this is part of a regular expression, it's not quite the same as just being that symbol. It's actually shorthand for the set containing that symbol, because a regular expression always evaluates to a language. So the symbol A, just a symbol, member of the alphabet. The string A, it's a string with one character, the symbol A. The regular expression A, well, that's a shorthand for the set containing A. Hope you got that. Likewise, the empty string is a regular expression. And here, that's short for the set containing the empty string, kind of by analogy to the previous single character. And then finally, the empty set is not shorthand for anything. It just means, well, I guess it's always shorthand because it's a special symbol, but it's short for itself, the empty set. So these are sort of the base cases of our inductive definition. And then regular expressions also encapsulate all of the expressions we can make by concatenating these things, taking a union of these things, and using a star operation on these things. So in particular, if we've got two regular expressions, R1 and R2, their union, R1 union R2, is a regular expression. So R1, R2, remember, they're both languages, they're both sets, their union is a set. Likewise, R1, R2, which is the same as short for concatenating R1 and R2. Or just to make things easy on ourselves, we're dropping the little bubble. That's also a regular expression. And finally, R1 star. The star of a regular expression is a regular expression. So these are sort of like our inductive steps in our inductive definitions. So any expression you can make by starting from base cases and using these operations to build up an expression is a regular expression. I also want to write down some common shorthand, which might as well be part of the definition, even though technically it's shorthand for some of these other operations. In particular, common shorthand, if R is a regular expression, we'll write R plus to mean R concatenated with R star. So whereas R star means 0 or more copies of things from R, R plus, because you're always concatenating at least one thing, means 1 or more copies of things from R concatenated together. Likewise, we've got shorthand for using sets. So if S is some set, like for instance, A, B, C, then S interpreted as a regular expression is a shorthand for A union B union C. In other words, if I use a set as part of a regular expression, it means take exactly one thing from that set. So if I had SS, that would be S concatenated with S. Take something from S, concatenate it with something else from S. And then finally, R to the kth power, where K can be any number. That just means concatenate R with itself a bunch of times. So if I write R to the third power, that means take 3 things from R and concatenate them together. So those are our most common shorthands. I'll give you an example of something else which is almost a shorthand because it gets used so much. Very frequently, you'll see the alphabet symbol sigma used as a set in a regular expression. So for example, if sigma is the binary alphabet 0, 1, then if I wrote, well, let's put it all together. How about sigma squared, sigma plus, yeah, that's a good example. Sigma squared, that's just sigma concatenated with itself. Sigma plus is at least 1 copy of sigma, so that's sigma r star. So this thing is equivalent to 3 sigmas followed by sigma star, which in turn is just 0 cup 1. Remember, that's how we interpret sets. Sorry, this is not a set, it's an expression, so I could have just written it in parentheses. 0 cup 1, 0 cup 1, 0 cup 1 star. That means pick something from the set 0 and 1 3 times, concatenate them together, and then concatenate 0 or more copies onto the end. So that's it for the definitions. I want to do a few quick examples. So 0 star 1 0. Well, this means 0 or more zeros concatenated with 1, concatenated with 0 or more zeros. So 1 is in the language represented by this regular expression, so is 0, 0, 0, 1, 0. You could also do 0 union empty string concatenated with 1 union empty string. So this means pick something from the first set, either the string 0 or the empty string, and then concatenate it with something from the second set. So that gets us 0, 1, 0 epsilon, epsilon 1, epsilon epsilon. And because epsilon, as always, is the empty string, this is really 0, 1, 0, 1, and a single empty string. Couple last examples, because they're sort of special cases. They're a little weird. They make sense with the rules when you think about them, but they're the kind of thing you wouldn't think about up front. So remember, if I'm evaluating something concatenated with the empty set, like 0 union 1, concatenated with the empty set, what this really means is pick something in the set 0, 1 and concatenate it with something in the set open brace, close brace. So because I can pick something in 0, 1, but I can't pick something in the second set, the only possible thing I can make by doing this, well, it's actually nothing. This gives me the empty set because there's no way to pick something from that second set. Another slightly weird one. If I take the star operation on the empty set, well, if I read it literally, it says concatenate 0 or more things from the empty set. And you might think this is just the empty set, but I can concatenate 0 things chosen from an empty set. And if I concatenate 0 things chosen from the empty set, I get the empty string. So that's what this evaluates to. So those are our 2 strange examples. That's all for this video, the lightning review on regular expressions. So thank you for watching. See you in class.